Hey friends, welcome back to our YouTube channel vlsichaps. In the series of learning embedded systems, today we will be talking about what is memory management in operating systems. So let's get it. You might have questioned that what is memory management and why it's required. So let's get that first. So in this diagram, if we can see, then to execute any process, it should be within this main memory. Process must be laid within this main memory to execute. Now CPU's task is to have multiple processes running on at the same time. That is why it's called multitasking, right? Now, in order to do that, in order to serve that purpose, maximum processes should be loaded within this main memory. But we have the memory size limitation. We cannot have unlimited size of memory. So, in order to make this particular process loading within this main memory, what we can do is we can arrange the blocks of the memories in such a way that we can have multiple processes executing within this main memory. So to do efficient job of the CPU in such a way that it can have maximum performance and its performance can be made more efficient, we require memory management. So to optimize memory usage of the operating system, the processes as well as the rest of the programs, CPU should be able to allocate the block of the memory whenever and in whichever form it's required to all three entities so that they can execute their operations efficiently and ultimately the CPU utilization becomes less and the execution becomes faster. So this is why the main job of memory management is required. Now in order to optimize CPU utilization, one should be knowing that how this CPU is utilized by the process. So let's understand that first. Now consider that I have one process which is executing within the main memory and its ideal time is 50% because normally not every process is continuously using the CPU. It must have some ideal time. So in this case, if I use this formula, then I number of processes is 1 here and the process block time or process ideal time is 50%, which will be 0.5. So CPU utilization will be 1 minus 0.5 is equal to 0.5, which will be 50%. Now instead of 1, let's take 2 processes and both the processes have ideal time similar, which is 0.5. Now here processes are 2, so n will be 2. If I use this formula, then 1 minus 0.5 raised to 2, that means 1 minus 0.25, which will be 0.75. So now the CPU utilization will be almost 75%. So if we increased one process, CPU utilization will go from 50% to directly 70%. So the point here is that the more number of process you will load into the main memory, the CPU utilization will be going to get higher. So the task here is that how we will be able to optimize that, and that is what we will be learning in the next slides. So the task over here will be maximum number of processes should be able to execute within the main memory to utilize the CPU effectively. So how we will allocate the blocks in to serve this purpose. So let's see that. So we have various methods to allocate the memories. One of them is fixed partition based. So in fixed partition, by default, memory block will be divided into the fixed size of the memory blocks. That size will not be changed. So if let's say I have a whole block of main memory which is divided within various parts, each of block is of 4 MB. Now if I have process who is whose size is less than 4 or equal to 4, then it will be able to load in this main memory. But if the size of the process is greater than 4 MB, then it won't be able to fit into this main memory. So this is what one limitation we have, that the allocated size of the block if it's lesser than what the actual process is needed, then that process won't be able to load in this main memory. Also, there are chances that the process size will be less than the allocated memory block. Here in the second block, we can see that the size of the process is 3 MB. So we have that 1 MB left. Now this 1 MB is not used unless we have any process which is waiting outside, whose size is of 1 MB. So this is useless. This portion of the block will useless. Also, due to this useless part, we cannot able to load another processes because the limitation here is that we should every process should have contiguous block of memory in order to load into the memory. But here we do not have contiguous block. Here we have 4 MB free, but here we have 1 MB. These two are separate, they are not contiguous. If they would have been contiguous, then we would be able to load 5 MB of process. But we have that limitation in fixed partition. So this unused space will cause the internal fragmentation. That is cause the internal fragmentation. Now, what is external fragmentation? Let's first consider this block of memory. In this case, we have 4 processes loaded already and there is 2 MB of space available. Now let's say second and fourth process has done their job and they are leaving the main memory. So we will have total 8 MB plus 2 MB, 10 MB of memory available. If we have the process waiting outside like 8 MB or 10 MB, then they both process will be able to load. But the case here is that this 4 MB of block which is freed right now in this case and this 4 MB of block, they both are not contiguous. They both are separate. If they would have been contiguous, then this 8 MB of process would be able to load. But this is not the case. Likewise, if these all 3 blocks would have been contiguous, then this 10 MB of process would have been able to load it, but that is not the case as well. So this is what is called an external fragmentation. Though we have enough size available to load any external process, but we are not able to do it because of the fixed partition, because they are not contiguous. And because of this, the degree of multiprogramming, that means the number of processes that can lie inside this main memory, is also reduced. Now, in order to resolve few of the scenario in fixed partition, we have dynamic partition. So in dynamic partition, what happens that the block of the memory will not be fixed by default. It will be vary based on the size of the process. So that block will be allocated to any process only at the runtime. That means whenever the process loads into the memory. So size of the partition will be the size of the process. So here we do not have an internal fragmentation. The reason is we will not have any free unused space because the process will be of the size of that block will be of the size of the process. Also, due to this property of dynamic partition, we will have multiple processes within this main memory. So the degree of multiprogramming will also be higher. And of course, the limitation of the size of the process will be completely reduced because in fixed partition, there are the chances that we might have the process whose size is greater than the allocated one, but here the size will be allocated just exactly what the process size is. So that limitation will also be gone out here. The only part that in dynamic partition also that causes the drawback is that external fragmentation. So we have size of the block just exactly the size of the process. But again, if the process completes its task and leave the memory, then if those blocks will be just like this, separate from each other, not contiguous, then the same problem will be happening, which will be caused the external fragmentation. So this is what the limitation we have in case of contiguous memory allocation techniques. We do have one solution to avoid the external fragmentation, which is compaction. Now in compaction, what happens is whatever the free size of the blocks that we are having, that will be merged and combined together into one free size of block, and all the used size of blocks will be combined together, and that will be separate out. So here we can have the we can reduce the drawbacks of the external internal fragmentation, because the free partitions are merged, which can now will be allocated according to the various needs of the new processes, and this technique will be called as an defragmentation. So the thing what we are here doing in this compaction is that we are making the various free blocks in a form of contiguous form, so that many number of processes will be able to load. But here the drawbacks is that whatever the free space that whatever the used space that we are having, that all will be transferred from one place to another and will be merged. So there, in case of very huge or complex programs where the memory size is quite huge, at that time the huge amount of time will be invested in order to this transferring mechanism and merging these blocks. So during this process, CPU will not be able to do anything. It will remain in its ideal state. And that is why we won't be able to utilize this CPU effectively. And our purpose will not be served effectively. So there are ways that we can use these particular techniques by which we can make more CPU utilization effective. In case of contiguous, there are limitations, but in the next video, we will be able to see that what is non-contiguous techniques in which we can have all the drawbacks solved. So during that time, you can make the most with our channel VLSI Chaps. You can follow us on various platforms mentioned here. You can be the part of our community and help other people grow along with us. So thank you for watching this video. Please do like, share and subscribe. If you have any comments or doubts, we have our comment section. Till then, goodbye. Thank you.